Hello, I'm Johnny, a Marine Ecosystems Research Technician at NOAA PIFSC, and this lecture I will be walking us through model building in Agisoft Metashape. And so now that you've gone through an overview of what Agisoft is and what it can be used for with Nathaniel, I'm going to be taking us through some of the settings and workflows of building your own 3D models using the Agisoft Metashape program. And so essentially we'll be going through the basics of processing images to create 3D models that can be used for visualization and photogrammetric analyses, with the goal of this lecture to introduce the general processing workflow, followed by a demonstration of model processing in Metashape from Nicole. And while we'll be going through some specific settings within Metashape to process our models, I really want to highlight that this is not meant to be prescriptive, but rather a way to get your feet wet within the Metashape interface. These settings and workflows will change based off your individual goals, but the main takeaway from this lecture will hopefully be the ability for you to follow along and create a 3D model from a set of images. So once you have your images that you are ready to process and a basic 3D model created, you can do a lot within the Metashape platform to improve how your models are created on the left side, and how well reconstructed your reef landscape or object of choice will be. We can also create a variety of products like these shown on the right side in Metashape. However, we really won't be talking about these more advanced settings and products in this lecture, but we will be touching on them a bit later in the course when we go into more depth about how you can leverage some of the 3D modeling approaches to meet your project visualization and or other analytical goals. But for this lecture, we'll really only be focusing on the basics of processing in Metashape, going from an image set to aligning those images together and creating a 3D dense point cloud of an object or a reefscape in this example. The images that you collect are the most important part of the model building process, and without an image collection effort of sufficient quality, as has been previously talked about, which again will depend on your project goals, it can be hard to make a good looking model and a well reconstructed object. After you have your images, you will align them together to create a sparse point cloud, an SPC as we call it, which is essentially the skeleton or geometric basis of your 3D model. The sparse point cloud is created from detecting features in images, matching those features across multiple images, then triangulating those matched points across to reconstruct the basic 3D structure of your object. Then, once you have the structure of your model created, Metashape creates a dense point cloud, or DPC, which fills in the gaps and reconstructs the finer details of your 3D object. The dense cloud is the basis for visualization and analysis of the model you've created, and can also be used as a basis for creating more of these advanced products like orthomosaics, DEMs, and 3D meshes. But again, we won't go through those products right now. So now that we have a basic understanding of the workflow, we can start to go through how these processes look in Metashape, which again is the program we are using to create 3D models. When you open Agisoft, a blank screen will look like this. And on the left-hand side of the window, in red, you have the workspace tab, which basically shows all of the components of your model, which are all grouped together in chunks. Chunks are how Metashape organizes individual models, and if you needed to have different models within the same project file, you would use multiple chunks. In the middle of the window, you have the model pane in purple, which is where your point clouds and products created will be shown. You can rotate around that model plane with the navigation ball highlighted blue, as well as using a right click and drag on your mouse to move around the model, and a left click and drag to rotate your model or object. The bottom of the screen is the photos panel, which will show the images that you import into Metashape, as well as any information about them, like model quality and other important metrics you might need. Now that we're oriented to the Metashape layout, we can start going through the processing workflow. So the first step is to import your images by going into Metashape, in the Metashape workflow tab, and choosing either add photos or add folder. If your images are the only thing in that folder, you can use add folder. So once your images are loaded in, they will show up in the photos pane like this. And so after you import the images for one model, you can align them together to create the first 3D object in our workflow, the sparse point cloud, which again provides the bones or underlying geometry of the 3D model. When you click on Align Photos under the Workflow tab, this box in the center will pop up, allowing you to choose settings with which you align your images. The default settings should be as depicted here, but to restate it again, Metashape builds the sparse point cloud by finding the same features across multiple images. So basically it finds a given number of features in each image, then tries to match those points into other images. The number of features it finds in each image is referred to as key points, and those are detected based on the key point limit shown in blue that you set in this Align Photos box. The most common values for key point limits are from 4,000 to 40,000 key points. But as with everything that we'll go through, this will depend on your project goals. But generally, using a higher value of key points can allow for better control to filter for potential errors in the construction of model geometry. But again, as you increase the key point limit, you use more processing power and time, which you may not have. The second value that we can change is the tie point limit. Tie points are created when key points are matched across multiple images. And this value, again, will be dependent on the key point limit and your project goals, but common values are from 0 to 10,000. If you want Metashape Metashape to keep all of your matched tie points, you can use a value of 0, which creates the densest point cloud for a given key point limit. But you can also set a tie point limit to be a larger value than 0, but still lower than your key point limit, which will only keep a subset of the key points matched up to the number set in that tie point limit. So then you can hit OK, and your model will start processing. So once the images have been aligned and the alignment steps have finished processing, hopefully after about an hour or so, you will have a nice looking sparse point cloud with few large gaps. You really won't be able to see any features in too much detail, but you should be able to see if there are any large errors within the model construction. Some common errors are large holes, misaligned or non-aligned images, or floating points, all of which are usually the result of issues within the image collection effort. Large holes and non or misaligned images generally come from poor overlap in images, and floating points often come from background noise or from large angles in camera orientation. Underwater, this would look like taking pictures with lots of blue water, or if the images are not quite as perpendicular or top down to the reef bottom as we would want, as was discussed in the image collection lectures. Again, here's a quick example of a sparse point cloud that has a major alignment error. We won't go through how to fix this issue right now, but we will talk about how to fix some of these problems to create cleaner models later in the course and through the lab sessions. One way we have a nice looking sparse cloud, once we have a nice looking sparse cloud, we can build the highly detailed dense point cloud. The dense point cloud essentially fills in points based on the sparse point cloud, but will only build the dense point cloud over points contained within this gray bounding box shown here. Now this should automatically encompass the entire sparse point cloud, but it's a good idea to double check and resize the region box if needed. Click on the resize region icon in the blue box shown here to see the region, and if needed, use the blue dots in the corners of the box to change the box size to cover the entire sparse point cloud or the part of the sparse point cloud that you want to turn into your dense point cloud. Now we can finally build our dense point cloud. Again, here are the default settings, but as with the image alignment steps, there are things that we can change about how to build the dense point cloud. The main one to focus on is the dense cloud quality, where higher quality models will be a lot more detailed and have more accurate geometry, but can take a lot longer to process. The default is to build a high quality model, but we generally also process models on medium, which saves processing time, but will not be as detailed because it downscales the image quality. You can also use low quality, which does not take very long to process, but you have very little detail in the dense point cloud. Or you can run ultra high quality, which retains all the detail from the images, but it takes a very long time to process and takes up a lot of storage space. So once you hit OK in the dense point build dense cloud box, the dense cloud will start to run. This will likely be the most time-intensive process in model processing, and processing on high quality could take anywhere from 1 to 12 plus hours, depending on your processing settings, and will increase as you have more images and as you have a more structurally complex model that you are building. So once the dense cloud has finished processing, a highly detailed 3D model will be created. Again, we won't go into cleaning up the model here, but it's a good idea to check again for large errors like holes and other floating points in your model. If everything looks good, then you've now built your very own 3D model from scratch. And so to recap, we went from importing images, which land in the cameras folder, to aligning those images into a sparse point cloud, which are the tie points, to creating a dense point cloud, which is created from first building depth maps and then the dense point cloud. And then once all of this is done, we can continue in Metashape by creating more products from these basics, or by exporting your dense cloud to another software for further uses like visualization and analysis. And now that we've gone through the general steps in creating the model in Metashape, Nicole will go through a demonstration of the whole processing workflow in Metashape, so you can all see how these steps work together. Thank you for listening, and happy model building.